Hello and welcome to helpyourmath.com. In this video, we are going to look at calculating inverse trigonometric functions when inverses aren't what they seem. Very ominous warning right there in the title. Well, what I'm referring to is there's a truth about a function and its inverse, and that is when we look at the composite function. So if we look at f inverse of f of x, and the final answer should be x. But that only works when x is in the domain of f and in the range of f inverse. And we might know that with our trigonometric functions, we only look at a little snippet of the graphs because they don't pass that horizontal line test. The sine function itself does not have an inverse, right? We just look at, it looks like this. We only look at a little piece from down here to up here. So that way we know that it's going to have an inverse function. Let's just review what we're looking for with our inverse functions. So we have sine inverse, cosine inverse, and tangent inverse. And remember that each of these have a second name too, a synonym. We can say y equals arcsine of x. And arcsine of x is the same thing as sine inverse of x. Those are synonymous with each other. I put the graphs on here as best I could. And we can see from these graphs, the domain for sine inverse is from -1 to 1. And those are included, so I use the brackets to indicate that they're included. And the range is from -π/2 to π/2, where again, those are included, so I use the brackets. Now, why -π/2 to π/2? Because if you think about the unit circle, I like relating everything back to the unit circle, and on the unit circle, -π/2 to π/2 would include quadrants 4 and 1. And sine is negative in quadrant 4 and positive in quadrant 1, so that's going to include everything in between -1 and 1. Cosine is a little bit different. So cosine, the domain is still from -1 to 1, but the range is different. We can't use quadrant 4 because cosine's positive in quadrant 4. So instead, we use the range from 0 to pi. So that would be like quadrants 1 and 2, cosine's positive in quadrant 1 and negative in quadrant 2. Tangent is a little bit different. Tangent inverse, the domain is all real numbers actually. And the range, if you can see, there are horizontal asymptotes at -π/2 and π/2. The range is going to be all the values in between. Because we don't include the endpoints with tangent, we do put parentheses around the values. So it's -π/2 to π/2. So we do want to keep this information in mind as we look at examples of calculating what should seem so simple, but actually it can get quite complex. Let's start off with the nice ones though. Okay, so we have cosine inverse of cosine of π/3. Now, π/3 is in the domain of cosine, and it's in the range of cosine inverse, because remember the range for cosine inverse was from 0 to pi. So that's good news. What this means is this is a true function and inverse composite function where this will cancel with this, and we end up with π/3 is our final answer. Yay! Well, that was lovely, wasn't it? I think so too. Let's try it again. Here we have tangent of arctangent of 0.61. Is 0.61 in the domain of arctangent? Well, yes, because everything is. Is it in the range for tangent? Yes, it is. Because it's in between -π/2 and π/2. We have a winner, so that means that this will cancel with this, and we end up with 0.61. You might be saying, wait a minute, at the beginning you said there was a trick. But keep in mind here, everything worked out. What was in the domain was in the range of the inverse and vice versa. What about this one? We have arcsine of sine of 7π/4. Can we just cancel out the arcsine and sine? We cannot. Why not? 7π/4 is not in the range of arcsine. Remember the domain for arcsine was from -1 to 1, and the range was from -π/2 to π/2. Well, 7π/4 is much bigger than π/2, so we can't just play that game. What we can do instead is we can break it down and do this step by step. So we start, just like with any composite function, start with the inner function. What is sine of 7π/4? And if you get stuck with that, you can think of A, the unit circle, or B, just graphing this and seeing what we end up with. So if I was to graph this in the coordinate plane, 7π/4 would terminate in quadrant 4. So here's 7π/4. That's my angle measure. And then this right here would be our reference angle, and the reference angle here is π/4. Now, what I know is that sine is negative in quadrant 4. So that tells me that whatever this value is, it's going to be the negative of sine of pi over 4. And sine of pi over 4 is negative root 2 over 2. So now I have negative root 2 over 2. Does that meet the criteria for our arc sine? Yes, it does. So we have arc sine of negative root 2 over 2, and this would end up equaling negative pi over 4. It's negative, so we know it's going to be that terminating in quadrant 4, and we need to make sure that it's within the specified range, somewhere in between negative pi over 2 and pi over 2. So we do this and we end up with negative pi over 4. A little bit sneaky, but I do suggest just doing it one step at a time if you find it confusing. And always think back to that unit circle and what's allowed in the domain and range for each of these. How about in our next example? Our next example, we have cosine inverse of cosine of 4 pi over 3. Are we able to just cancel out the cosine inverse and the cosine? Let's check. The domain for cosine inverse is from negative 1 to 1, and the range would be from 0 to pi. Unfortunately for us, 4 pi over 3 is bigger than pi. It is out of the range. So my suggestion is do this one step at a time. Start with this inner calculation, cosine of 4 pi over 3. Let's just evaluate this, and then we'll come back to that cosine inverse. So cosine of 4 pi over 3, if we were to look at this, 4 pi over 3 terminates in quadrant 3. So it'd be like right here, this is 4 pi over 3. Our reference angle here, theta hat, will be pi over 3. So that's the difference. This is the difference between 4 pi over 3 and pi. And so let's see, it terminates in quadrant 3 where cosine is negative. So that means that cosine of 4 pi over 3 is the same thing as the negative of cosine of pi over 3. And cosine of pi over 3 would be a half. So this is going to equal negative 1/2. So now what we want to calculate is cosine inverse of negative 1/2. That negative 1/2 is within the domain now, so we have an allowable domain. We want to figure out what it's going to be. And here's where cosine can get really, really tricky as compared to sine or tangent. With sine or tangent, we can just say, oh, it gets to be the negative of whatever the reference angle is. But cosine, not so much, because remember, we focus on quadrants 1 and 2. I don't know why this thing expands on me, but it does. Okay, so where is cosine equal to negative 1/2 in between 0 and pi? Well, that would be in quadrant 2, and that would be where the reference angle is pi over 3. So we're terminating in quadrant 2, and the reference angle is pi over 3. So to figure out what the actual angle is we're going to take pi, because that's the negative x-axis, and subtract it by pi over 3 to get it to be in quadrant 2. Well, pi is equivalent to 3 pi over 3. 3 pi over 3 minus pi over 3 is 2 pi over 3, and that would be it, 2 pi over 3, which does lie conveniently between 0 and pi. I know it's really, really tricky, so let's go through it again. First, we started by just evaluating cosine of 4 pi over 3. Cosine of 4 pi over 3 gave us negative 1/2. So then we go plug that in, we replace this with negative 1/2, and then we have to say, okay, so where in the allowable range is cosine equal to negative 1/2? And that would be in quadrant 2, right? Because our choices are quadrant 1 or quadrant 2. And that would be pi over 3 would be our reference angle. So the angle that terminates in quadrant 2 with a reference angle of pi over 3 is 2 pi over 3. And that would be our final answer, 2 pi over 3. Our last example. You're doing great. This one's going to be nice again. We're going to go back to quadrants 1 and 4 where things are a lot friendlier. We have arctangent of 7 pi over 6. So the domain for arctangent was negative infinity to infinity, but the range was from negative pi over 2 to positive pi over 2, and 7 pi over 6 does not fall in that range. So again, we're going to do this one step at a time. Step 1, we're going to focus on tangent of 7 pi over 6. Tangent of 7 pi over 6, so that would terminate in quadrant 3. Here's 7 pi over 6. Our reference angle here is going to be this angle right here, will be pi over 6. So I'm going to call that theta hat, is pi over 6. This is quadrant 3 where tangent is positive. So tangent of 7 pi over 6 is the same as tangent of pi over 6, and in either case we end up with the square root of 3 over 3. Awesome. Okay, so now we know that tangent of 7 pi over 6 is root 3 over 3. So now what we want to calculate is arctangent of root 3 over 3. So where in between negative pi over 2 and pi over 2 do we have something, some angle that when we take tangent of it, it equals root 3 over 3, right? Because that's how I like thinking about this. I like saying, okay, tangent of what will give me root 3 over 3 in the allowable range. And that would be at pi over 6. So we do all this work and we see that arctangent of 7 pi over 6 is equal to pi over 6. We did it. We survived these together. These have been tricky inverse trig functions. Thank you for stopping by.